Aging, at its core, is not just about wrinkles or worn-out joints. It's about how your cells remember who they are. And that memory, it turns out, is encoded not in the genes themselves, but in how those genes are read and expressed. Welcome to the wild, beautifully complex world of epigenetics, where gene expression is shaped not by fixed sequences, but by flexible instructions, chemical tags, and chromatin folding patterns that tell your DNA when to whisper and when to shout. In youth, this system hums along smoothly. Genes toggle on and off in elegant, coordinated rhythms. But with age, these regulatory circuits start to glitch. You get global hypomethylation, too many genes turned on, site-specific hypermethylation, especially at tumor suppressor genes, because irony, and an overall loss of chromatin organization. It's like your DNA went from a symphony to a jazz band where everyone's playing a different tune, and half the musicians are on fire. So the question arises, can we reset the epigenome? Can we nudge our cellular software back to a more youthful, responsive, coherent state? Here's where things get trippy. Because recent whispers in the scientific underground suggest that psilocybin, yes, the compound that makes trees breathe and your cat seem deeply philosophical, may do exactly that. While the evidence is still early stage and mostly from animal and cellular models, we're starting to see clues that psychedelics don't just alter consciousness, they alter gene expression patterns. And not temporarily. Some of these changes appear to last weeks or even months, long after the drug has left the system. That's an epigenetic signature, if ever there was one. Take DNA methylation, the process of adding tiny chemical flags, methyl groups, to cytosine bases in DNA. These marks usually act as off switches for genes. Aging typically comes with widespread methylation drift. Important developmental and repair genes get silenced, while inflammatory and senescence-associated genes stay on like unwanted porch lights. Psilocybin and its relatives appear to influence methylation enzymes, such as DNMTs, DNA methyltransferases, and TT proteins that demethylate DNA, potentially recalibrating this aging-related imbalance. One mouse study even found that psychedelic treatment reversed stress-induced epigenetic marks in the prefrontal cortex. Could it also undo the methylation chaos of aging? It's too soon to say definitively, but signs point to maybe. Now zoom in further into the histones, those spools that DNA winds around like a thread. When histones are tightly packed, genes are hidden. When loosened, genes are accessible. Modifying these proteins through acetylation, methylation, or phosphorylation can dramatically shift what genes are turned on or off. Psilocybin may modulate histone acetyltransferases, HATs, and deacetylases, DACs, the enzymes responsible for these chromatin tweaks. This could help restore the youthful, dynamic chromatin state that cells lose with age, reopening regenerative and stress resistance genes while closing the ones that fuel chronic inflammation or cellular stagnation. And don't forget the serotonin receptor angle. Psilocybin binds primarily to the 5-HT2A receptor, which isn't just a neural party starter. It's also present on various immune cells and may influence transcription factors like CREB and NF-B, both of which are key players in the epigenetic aging game. Downstream of these receptors, you get cascades that can influence long-term potentiation, synaptic plasticity, and yes, gene expression across multiple systems. What's especially compelling is that these changes don't appear random. Instead, they often favor pro-repair, anti-inflammatory, and neurotrophic pathways, the very mechanisms we want to support in aging cells. Think increased expression of BDNF, IGF-1, SIRT1, and reduced expression of pro-apoptotic and pro-inflammatory genes. The direction of change suggests a targeted, almost intelligent form of epigenetic modulation, more like a cellular meditation retreat than a molecular riot. Of course, we're not quite ready to replace your multivitamin with microdoses of magic mushrooms. But if future studies confirm that psilocybin can gently reset the epigenome toward a more youthful configuration, it might join a growing list of natural compounds, like resveratrol, sulforaphane, and quercetin, that act as epigenetic tune-up agents. Only with one key difference: psilocybin's simultaneous impact on mood, motivation, and meaning gives it a psychological edge that purely biochemical tools lack. In short, psilocybin might help cells remember how to be young again, not by rewriting DNA, but by re-editing the margins of the script. It's not genetic engineering. It's not hacking. It's more like gentle persuasion. A quiet, molecular nudge back toward vitality, complexity, and balance. And if the idea of mushrooms whispering sweet nothings to your histones sounds like science fiction, well, so did the idea of reversing aging a decade ago.